I'm trying to do a bunch of stuff in that period, like practicing. So she's been letting me.
That wasn't your main reason going.
One of our games is at 7:30.
Ours is tomorrow morning.
It's so yes. Wait, where?
Is that like
That's bad.
No, ours is at Clear on Friday.
Nice.
Oh wait.
Who's your number 2?
Whenever you can make it, man.
Ours are at the Met.
Oh,
And then we're,
we like usually like homework today because we learned everything.
I mean, unless you
You might have changed
I printed it out.
I woke up and I was like, I was thinking like, and then I woke up at 6:30 and I was
So I this is that I forgot to study, and I thought like the rest of my sentence that I made out in my head was for this.
All right, guys.
all right.
Everybody know how to graph?
Yeah.
Anybody have any issues?
No.
Anybody not check their work and have no idea whether they have issues?
No issues. I forget.
What?
Maddie checks her work.
Oh, look at Maddie.
Crossing out the thing that
You said that. You said
All right, guys.
check.
Focus. Only thing I have left in this chapter, which should leave us probably half this period, and then on Monday, since it's kind of a long review sheet, is to talk about how to look at a function and find the equation from it. You might remember this from last year. You're kind of working backwards. There's one small part that tends to get people a little bit. And then also to remind you on, I think I have it scheduled for the 7th of October, although I might move it. But as of right now, it's about the 7th, which is not this coming Thursday, but the following Thursday. Everybody with me? Phone girl? All right, so maybe a week from this coming Thursday, we're going to have our 9 weeks test. So if you're sitting on a crappy test and you're like, ooh, I have to drop this thing, blah, 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 make sure that you start preparing for that. If I were you, I would be studying all of my review sheets from the test, because that's where I'm pulling your test from. And it will just go through this test on Tuesday. All right, the stuff that we began on Wednesday, we won't have time, we won't have time to finish it. So you won't have to worry about that being on the 9 weeks test.
When is the 8th and 9 weeks?
The end of 9 weeks is the 8th, not this coming Friday, but the next.
Oh,
If you
So-
move to the 9
so we
weeks,
have 2
then
weeks.
you can move it
We
like
got time.
I might move it up to a Wednesday. I might move it to a Friday. Y'all with me? Okay, so just be thinking about that. My 9 weeks test historically, if you've been in here before, you know that they are not. Did I give y'all 9 weeks last year?
No.
No, we have
I may have given you the third 9 weeks. Yeah, I was underwater in the first 9 weeks, so I didn't have time to even breathe, much less create another set of tests. So, but anyway, if you remember that third 9 weeks test, it's not like I grabbed the hardest problems from every review sheet, but I'm also not grabbing the easiest problems. So if there was some random, obscure, kind of tricky problem on there, there's a good chance that's not on my 9 weeks test. But again, your definition of obscure and tricky might be different than mine. So, but focus on kind of the main ideas. Those are the main things. That's what I'm trying to do on a 9 weeks or a semester exam. All right. Okay, so back to what we're doing today. This is the last part of this chapter. And when I look at this graph, you could see a number of different things. Like you could look at this and see a sine curve. You could see a cosine curve. You could see a negative sine curve. You could see a negative cosine curve. But all of those graphs would have different equations. And on a test, I really don't want to work this problem 4 separate times to grade and have it match yours. So what I do is I tell you, hey, I want you to give me a positive cosine. So on a positive cosine curve, there can still be a little bit of difference, but the only thing that will be different possibly on yours than mine is the C value. Okay, because you're going to have the same D value, you're going to have the same amplitudes, and you're going to have the same length of the period. So that's what That's what affects A, B, and D. But the C value, the little bx minus c, that value can be different based on your phase shift. So if you want your answers to match my answers on the test, I mean, I'll pick any C value that works. But on the keys for the reviews, if you want it to match, pick the C value or pick the phase shift that's closest to this x-axis. Are you with me? And if you do that, then your answer will match the book and you'll know if you're doing it right. Are you with me? Okay, so for instance, right here, if I'm trying to find a positive cosine curve, this is kind of how I'm thinking. I'm thinking, all right, there's some function out there and there's some D value. I'm telling you it's positive. There's some A value. I'm telling you that it's cosine. And then there's going to be some B value times X minus some C value. Because remember, the general formula is always Bx minus C, right? And if the C ends up being negative, when you plug it in, that's what makes it plus. The C value is positive. When you plug it in there, it stays negative. And that makes sense if you think about shifts going in the opposite direction of the sign. So your job is to come in here and figure all those values out. So the first thing, probably the easiest thing on a sine cosine curve is the what? That D value that runs right through the middle. So you can see your D value is at a value of 1. So you come up here and you say D is 1. And then probably the next easiest thing is what? The fact that your A value, you went up 3 and you went down 3 from this D value. So that tells you that your A value is 3. And you're halfway there on this problem. But the rest of it's the trickier part. So now you've got to figure out how to find the B and the C. Well, normally we take what? We find what first? Like if you were graphing it, you normally find the phase shift, then you use the period, right? But the phase shift involves 2 variables, right? The period only involves 1 variable. So what I'm going to do is I'm going to take that period equation, which remember was period equals 2 pi over B. But this time I'm looking for B, right? B is what I want right here. And I should be able to figure out the period by looking at the graph. So what I need to do is draw a box around where the positive cosine curve would exist. So what does a positive cosine curve look like? Starts high and ends high, right? So put a box around a starts high and ends high. Okay, now there's a bunch of those, but again, if you want your work to match my work, you'll pick the phase shift to be the one closest to the y-axis. Now in this case, there's 2 of them. That one and that one are both 2 ticks away or pi over 2 away. So it doesn't matter. You'll see on my key, it'll say plus or minus. But if there was one that was closest, pick that and then your work will match my work. On the test, I don't care. Pick this if you want. Pick this if you want. I would rather you not, because then I have to actually do the math and see about this. I always had some bonehead who would I'm going to find a phase shift 500 miles down the road and be really clever. Gabe, not Cortez, but Kiana, and a guy named Grant Smith would always do that stuff too. Oh, coterminal angle. And he'd find one like a...
Kiana would do that solely to be just out of spite.
Yeah, he would always do it. So sometimes I would just go, "What's wrong?"
The worst part is,
and then make him sweat it. He'd be like, "What? No, this is right." I'm like, "I don't believe you." Anyway, do what?
The worst part is that he was always right too.
He's right a lot. Yeah. But that's a great example of how inefficiency doesn't work for you sometimes. You know. Anyway, you know that also. But whatever. So I need to find what I know about period. Now the great thing about period equal 2 pi over B is what does our slide rule tell us? So B is the same thing as 2 pi over the period, right? Now you don't have to memorize that. I mean, you can just take the period, which in this case is how much? The period is 4 tick marks. Can you see that right here? That's 1 period right there. All right, 1 period, and that is 1, 2, 3, 4 tick marks. And on this graph, 4 tick marks happens to be a pi. So if you want to, you can come over here and take the formula we already know. Period equals 2 pi over b, and you can plug pi in for the period, and then you can cross multiply and divide, and you'll easily see b is 2. But you could have also said, wait, b is 2 pi over the period 2. And it might be a little easier a lot of times. All right, so I know my b value. Great. Now I'm 3/4 of the way there. The last thing you need is what? Your c value. And your c value is going to come from what we know about the phase shift. All right. Now the phase shift, again, pick one of these. I'm going to pick positive pi over 2, but you could pick negative pi over 2. All right. Now, remember what you did to find phase shift. What did you do? You set this whole bx minus c equal to 0, and you solved, and the phase shift was what? What you got for x. So if you know the phase shift, you're basically going to still use that formula, right? You're still going to say bx minus c equals 0, but you're plugging the phase shift in for x and solving for c. Are y'all seeing that? So what you did before was solve for x. Now you're plugging your phase shift in for x. And since I already know b, I can use that b value here. I can use my phase shift there, and I get 2 times the phase shift, which appears to be pi over 2. And I can add the c to the other side, and I get c equals pi. And I'm done. And you're literally going to do this process over and over and over whenever you're dealing with sine, cosine, secant, or cosecant. Let's try it again. Here is now this, again, honestly, if I were to just look at this, I think positive cosine. But I'm telling you, it's a positive sine curve. So if it's a positive sine curve, you have to think a little bit differently. So starting out, we're going to say, all right, I'm telling you, positive sine, so plus, there's my d, there's my a, sine of, there's my b, x minus there's my c. And I'm looking for a positive sign. So what's the most obvious thing I can get out of this? And my d value appears to be -2. And the next obvious thing, I'm going up 4 and down 4. So it appears like my amplitude is 4. And then I need to figure out the length of my period to help me find b first. And it appears, how do I figure out period if this is a positive sine curve? Positive sine curve starts bumping up first. So that must be the beginning of the box. Bump up, bump down, that must be the end of the box. And again, there are a lot of boxes in here. But if you want your answer to match mine nice and easily, you will choose this. Right there's your phase shift, because that edge of the box is closest to the y-axis. But on a test, you can pick any one of these. Whatever. All right, but I'm going to pick this one. So what is that right there? That looks like, what, 1, 2, 3, 4, 5. That's 1/6 of the way to pi, heading left. So that phase shift is what? So that's a negative. That is a negative pi over 6, but I don't need that just yet. Right now, I see that it's 1, 2, 3, 4 tick marks is the length of the period, right? 1, 2, 3, 4. And what is 4 tick marks? It is 4/6 of a pi. Are y'all seeing that? Yes or no? 4 tick marks would be 4/6 of pi, or 2/3 of pi, 2 pi over 3. So the length of my period, which is 2 pi over b. If you do it that way, you're going to say, well, the period is 2/3 of a pi. And that's got to be equal to 2 pi over b. And you can kind of see pretty clearly b is 3. If you did it the other way and said b is 2 pi over period, then you're plugging 2 pi over 3 in the denominator. And when you multiply by reciprocal, you get 3 again. Either way, your B is 3, depending on how you want to go. And then the last thing, what do? So you take your bx minus c, set it equal to 0, take the b that you just got, plug it there, take the phase shift, which you know is negative pi over 6, plug it there, move the c over, and you get what? Negative pi halves. So if the c is negative pi over 2, then this graph ends up being what? Positive. So it looks like 3x plus pi over 2 because of the 2 negatives. Right? All right, so tangent and cotangent get a little bit trickier. And the reason why they get a little trickier, and some people don't think they're tricky at all, but this is where people tend to make mistakes on. Tangent and cotangent, sometimes, probably not on this one, but maybe on the next one, sometimes it becomes harder to see where that d value is, right? Because there's no high and low on it. So like if you're just eyeballing it, where do you see the d value?
1.
At 1, maybe at 2. I think it does end up being 1, but we're going to see. I'm going to show you some checks you can do. So if you end up being wrong, you'll know you're wrong because of these checks. Okay. Sorry, can you say it again? There's some echo in this. Yes, he did. Hold on. I have it. It is legible. Well, I mean, his handwriting is not legible, but I know his handwriting. Oh, no, nobody would know but me. 801. Yes. No worries. Okay, bye-bye.
Did they not read my thing?
They're like, is a hill is it legible? I was like, no. I guess you heard the conversation. That's funny. Okay. Like, there's nothing bad from that, is there?
I think so.
Okay.
What happened?
I mean, you didn't like forge your pass or something.
Oh, no.
Okay, yeah, you're good. No, I don't think that they could read it. And they were like, who was that? I mean, you know what it looks like. Have you seen, y'all both? Yeah. It just looks like,
You put it under the board before.
Yeah. I mean, I thought about like taking pictures of them all year long, doing like a collage. Maybe make some wallpaper, you know. All right, so right here, here's the way you go about checking to see if you're right. Okay, so if you're looking at this and you're like, okay, I think this would be it. Okay, now if that's it right here, and this is one way to go about it, I'll show you another way. If that's it, then remember that right there would be the middle of what? The middle of your ladder. So when you start thinking about asymptotes, right here, you look at it and you go, well, there's only really one vertical line I can grab. I'm not going to make you grab a vertical line that's not shown, because then it's, I mean, how would you know? I mean, so it's going to be something in there. If there's only one, you really don't have a whole lot of choices. But if there were like 4 in the middle, now you got to pick. Or if there's 2 in the middle, how do you know which one? Well, what you're going to do is draw these, take a good guess on your vertical line. You know, remember, it's got to be the same distance that way as it is that way. So when you get your guess, right, then you're assuming that would be the D line, right? Well, what's the check? The check is, remember, if you go halfway there and down, or halfway there and up, that would be your A value, right? Well, if you do that halfway down and halfway up, and on the way down it's 2, and on the way up it's 4, well, you have the wrong D value. So for instance, what if you had accidentally thought that was the middle of the graph, right? and you went, okay, this is my D value, all right, and then my vertical asymptote. Well, first of all, the vertical asymptotes would make no sense, would they? Right? You're looking at that and going, wait a minute, 2 this way, 4 that way. That's not the middle of the graph. But let's just say you really, and by the way, I can do this. Like right here, you might go, well, you would never draw that vertical asymptote like this, would you, Mr. Hurry? Never. But look, what if I had chopped the graph? Like, what if your graph stopped right here? Like, what if you didn't see any of this? I didn't show you that part, right? What if I only gave you this top part? Okay, and maybe I even made this go further. I mean, isn't it possible? Like if your graph looked like this, that you might go, oh yeah, look, it's following that vertical asymptote, it's following this. It's possible. I mean, you might go, that's not that possible. But if it was, it's possible you could think this. And if you did grab that D value and you mark the vertical asymptotes, your check would catch it. Because if you go halfway down and then halfway up, those distances aren't the same. Are you following me? So if that happens, remember, just don't forget to run that little check. Here, it's pretty obvious, but in the problem that we do next, it might not be as obvious. Okay, so at this point, you should be in pretty decent shape because you would have guessed these points were the D values. And if those are the D values, you run your little, you guess maybe those are the asymptotes. And then you run your little check and you go, all right, halfway down, halfway up. Oh, well, if that's the case, these must have been my amplitudes. And all of a sudden you see your little ladder or your H or whatever you call it. And you should be ready to go with a negative tangent. So starting off, you got your Y, you got your D value, you know it's negative, you got your A value, you know it's tangent, your B, your X minus your C, and you should be on your way to figuring stuff out. And at this point, you should pretty much see the same thing you saw before. So what is your D value? 1. Your amplitude? Up and down 2. How are you going to find your B? Okay, I can find phase shift. Am I going to use that phase shift? Why not? It's closest. Because that's not the phase shift. On every graph but tangent, the phase shift would be one of those asymptotes. But in tangent, we know what?
It's the middle.
It's the middle of the period. So middle of the period looks like this. And that value is what? 2/6 of the way to pi. So positive pi over 3. So that's my phase shift. But I don't really need that initially. What do I need initially? I need the period. And the period is 1, 2, 3, 4, 5, 6 ticks. So on this ruler, that's a pi. So what's my formula for getting that in? The period is not 2 pi over b anymore, but pi over b. So if you knew your period was pi, right, on this one, you plug a pi in there and your b value after cross multiplying or eyeballing it is 1. You use the other way, you're going to put the pi in there and it'll cancel and give you a 1. So I've got my, oh, by the way, my amplitude is 2. So my B value is 1. And now I go and find your C value using the B value in the phase shift. So now you come in here with your BX minus your C. Again, your B is 1. Your phase shift is pi over 3. And you can add C to the other side. And you plug that in there and that's positive there. Now it's negative here. Feels the same a little bit except for that junk at the beginning. All right, you're going to see the next one might not be as obvious. Now, if you're looking at it going, it's obvious. Great. If you're looking at it and saying, oh, that's not obvious, then remember, all you got to do is just guess a D value. Just guess it. All right? And then just run a little quick check. So, right, or guess the asymptotes, which is going to guide you to the D value. Okay, so check it out. Here's my positive cotangent. So I know I'm looking for some D positive, some A cotangent, some B times X minus some C. I know that. All right? I'm like the easiest guy to observe on the planet. They're like, well, we're gonna tell that guy he's been there 29 years. Normally they sit in here for like 30 minutes, and like every 3 years, the old people like me you still have to be observed. And they'll stay in here for like 30 minutes or an hour or whatever.
Did you used to get nervous?
Never. Only thing that irritated me about it was whenever they walk in, everybody in here gets quiet. I'd be like, quiet day. So that was always a problem. I mean, I know you're probably like, we're going to behave, but that's,
I put my mask on, right?
Oh, I didn't even think about that.
Okay.
All y'all wearing the chin strap. I got to do my sixth period class, and I kid you not, he's like this all the time. And I'm like I don't care. Like I'm ready for mask optional, right? So I mean, I'm just doing my part, and but every day I'm like, dude, oh sorry. 5 seconds later, chin. I mean, below his neck. He's not even like remotely faking it like Sophie is here.
Yes.
All right, so right here, can you eyeball right now and tell where the asymptotes are? See, it's not quite as apparent because you have two, and they're like almost right in the middle. So I'm going to intentionally, now if you're looking at it going, well, this one's like more in the middle than this one. I know that you say that, but again, what would happen if I only showed you this part of the graph? Like if you didn't see that, this part of the graph, would that theory still hold? Is this one more in the middle of this one? No, now this one looks more in the middle. So I'm just saying sometimes your theories will be off, and that's okay. It's just a guess. So guess if you want, but make sure you run your check, because if you guess wrongly, your A values won't match. Okay, so I'm going to guess intentionally wrong, right? So here's me guessing intentionally wrong. Those colors go together. Beautiful. Right? And if those were my asymptotes, doesn't the graph, the tangent graph, have to be right in the middle of those somewhere, like right on the D line? Right? Because remember, I'm always, when I look at this thing, that point is always right there. So if I have these drawn in, just the asymptotes, right dead in the middle, the graph needs to be crossing there, doesn't it? So I'm going to look at this and go, what's right dead in the middle? Now, it looks kind of like that, but you can see that it's a little off. Now, I can find one that's right on the money there and right on the money somewhere else. But if I had picked these, 1, 2, 3, 4, 1, 2, 3, 4, it's pretty close. Let's see if it worked. So if that's the case, then that would be the D value. Let's check A. So A tells me if I go halfway there and down, looks like at about 2-ish. But if I go halfway here and up, ooh, not 2-ish. Do you see how the A values don't match? Well, fine. You picked the wrong asymptote. So unpick it. So I'm going to go back and now grab a different asymptote. So maybe I grab that one. And when I grab that one, again, I look and I go, where would my horizontal line have to be? Well, it have to be right dead in the middle of this. Well, right in the middle, that looks like this, right? So that would be the D value. And then I'm going to quickly just check to see if my A values are the same. Halfway there, down 3, halfway there, up 3. Okay, I'm good. Are you seeing that? So it's just a matter of guessing and checking. Some of you are going to be able to eyeball that a little bit more clearly or a little bit more quickly than maybe others, and there's nothing wrong with that. But every year I have somebody who gets that wrong just because they didn't check the A value. So that's my graph. So let's see if I can figure out this equation. Positive cotangent. So I know it's going to be some positive cotangent bx minus c. And what would be my D value?
-2.
A -2. What would be the amplitude? Up and down 3. How do I find the B value? Yeah, the period again is pi over b. Taking longer than I thought. So again, it's pi over b. So I do what? Figure out what the period is. So how long is this period? 1, 2, 3, 4, 5, 6, 7, 8 ticks. On this ruler, what is 8 ticks? 2 pi. So if my period is 2 pi, then you look at this, b would have to be a half, but if you cross multiply or slide the b up and the 2 pi down, you can see when you cancel, you get b is 1/2. So there's my 1/2. And then the last thing you would do is take your bx minus c, take your 1/2 that you just got, put it there. What is your phase shift? Haven't really talked about, oh man, if the phase shift is 0, money. Just plug a 0 in there. There was no shift. So always pick a phase shift if you get lucky. And by the way, if you're thinking phase shift in the middle, remember, phase shift in the middle is only for tangent, right? All the other ones, phase shift is at the beginning or the end. So you could use this. You could take a 2 pi, plug it in there, and your c could be pi. You could take a negative 2 pi, plug it in, your c could be negative. It could be. I wouldn't count that wrong, but if you want your answer to match mine, pick the one closest to the y-axis, which in this case is 0. Right? All right, last couple. Find the equation of a negative cosecant. So a negative cosecant, right? What is a negative cosecant built off of? A sine. Now I'm going to graph or figure out the cosecant graph, but I'm going to base it all thinking like a negative sine graph. So I am going to, does it make sense that this is my d value running right through the middle?
Yes.
Does it make sense that at the bottom of those little mini parabola-like things and at the top, those would be where the amplitude marks would have been? So the only thing you need to do is figure out, because I'm really halfway there right now, aren't I? Right there, I've got what? 1, 2, 3, and then up and down 2. So I've got to sketch in there a negative cosecant graph. So what would a negative cosecant graph look like? Negative cosecant would be like you'd have to build it off of a what? A negative sine. So a negative sine would be a down bump and then an up bump. So where do you see that here? Where do you see down bump? Maybe down. That's a terrible color. Right here, maybe down there, and then maybe up there. Does that look like one? So to me, I can sketch that in there. This negative cosecant graph would have been built off that negative sine curve. So now I can tell the period. So the length of my period is 1, 2, 3, 4, 5, 6 ticks. What is 6 ticks? 6 pi. So my period here is 6 pi. So if the period, I'm back to 2 pi over b. If my period is 6 pi, when I cross multiply and solve, I get 1/3. And then which phase shift do you want to use? The one on the right, closest to the y-axis. Great. That would be 2 pi. So I come in here and I say, all right, bx minus c equals 0. I take the b, plug it in there. I take the phase shift, which is 2 pi, plug it in there. I move the c to the other side, and I get my 2 pi. And if it's positive there, it goes in, and now it's negative. And then the positive secant, exact same thing, but you're building. Everybody have this who needs it? Okay. And then 6. So same thinking. I'm positive secant. So y equals sum d, positive, sum a, secant graph, sum b, x minus sum c, right? And secant would have been built off of a cosine. So a positive cosine does what? Starts high and ends high. So starts high, comes down and ends high. Must have crossed there and there, because remember it kind of looks linear, like a linear V or a linear zigzag. You're sketching these in here. So this graph would have looked something like that, or something like this. I'm sketching 2 periods this time, but it's not necessary. So with that, I should be able to put a box, and the box is what I need here. Right? For a positive cosine to build my positive secant. So fill it in. What do you got? D is -3. Amplitude is 1, which if I was writing this out normally, I wouldn't write +1 secant. I would just write plus secant. But you need to fill it in. Fill in that value. Don't just leave it blank because it's a 1. And then once again, I need to use the period formula. If the period is 2 pi over b, what is the length of this period? 8 ticks, and 8 ticks is pi. So if pi is 2 pi over b, seems pretty clear when you cross multiply that your b is 2. And then lastly, if bx minus c is 0, take your 2, plug it in. What's your phase shift? Why not use, if that's 8 ticks, that would be a pi, 1 pi over 8, 1/8 of the way. So plug a pi over 8 in there, and it looks like c is pi over 4. So you plug a pi over 4 in there, and it changes it to a negative. Y'all see it? All right, I hope I sufficiently beat that in the ground. I guess that took a little longer than I thought. Anyway, you've got the rest of today, all day on Monday, to work on that review. Again, I know you're 2 weekends out, but it wouldn't be a terrible idea to start maybe looking over that 9 weeks test. I know some people are like, man, I got a 78. Like this is their thinking because they're not doing math at this. Like a parent told me their son said, and I know stuff gets lost in translation, but they're low grade.
Oh my gosh, that's the lyric Taylor Swift says. Sorry.
I'm sure she came up. So anyway, they have the 78, and the 78's dropping them to like an 88 average. And they're like, all I got to do, Mom, is make an 80 or above to get rid of a 78. True statement. But if I get an 80 and throw out a 78, what's going to happen to my average? Not much, right? If you really want to, now granted, if you make a 90 and throw out a 78, that's like getting 12 bonus points, kind of, right? You're replacing the 78 with a 90. That certainly could help you. But just doing well enough to get rid of a 78 or something like that by eking out an 80 or 81 isn't necessarily going to help you a lot. Now, if your lowest score is a 50 and you make an 80, absolutely. That's like getting 30 bonus points. I've seen people go from 81 Bs to As just like that, or from 77 Bs to sometimes even As, or at least high Bs. And you want to put yourself in a fighting position to get an A for the semester, right? So even if it's not an A this 9 weeks, you can scrounge out an 87, at least you put yourself in a fighter's chance. Or vice versa, if you're at a 77, or 72, get a 78 or something. Bring it up to the point where you got a fighting shot of getting a B for the semester. All right? Anyway, bottom line, it wouldn't hurt to start looking over those things because you're going to be surprised how much we've covered when you look back and how easy it is to forget stuff. Yeah, of course. Well, all right. You got big plans for the weekend? Yeah?
I'm going to Tampa.
Me and Sophie have.
Really? Oh, for soccer?
Me and Sophie
Cool.
have a soccer tournament that we're gonna win.
Yeah?
We're gonna win.
So y'all are on what team?
That's not the champion spirit.
Now you.
What team are y'all on?
03, I guess.
Oh, okay.
Oh.
And you're playing with who?
Teresa.
Teresa. In volleyball, y'all they're wearing y'all out this weekend?
What's relative?
I feel like
But you have like at least one match tonight and
I
then
remember we got 2 matches tonight, and then I don't even know how many tomorrow.
We won play that tomorrow, and we go to bracket play.
so how's playing time looking for y'all?
Oh, I read this.
Yeah,
Okay.
very
I went very little.
very little.
She played a lot last night though. Like a solid no.
He starts yawning.
You feel like you're getting it back?
He plays the next 30 minutes. I mean, he doesn't play.
It depends on
What position?
I mean, who you're playing with?
Yeah. Like if we're playing Spain.
Yeah.
I wrote it down somewhere. I'll show you. I remember, I wrote it down too, but I'm
Oh yeah, that's trophy.
Should I watch the video? No, I heard anyway. You got any weekend plans?
I do.
Lake, whatever.
A little bit of everything. We're going to a Cayo family weekend thing tonight with my daughter Caroline and my wife. And then we're staying at a lake house, believe it or not, of a student I taught my very first year here, who we just stayed friends over the years. He's like 40, how old is he now? He's probably 43, but he's like, he lives down in Mobile and he has a lake house at Lake Martin. He's like, here's it. Keys to the boat are on the counter. He's just so giving. We're like, okay, maybe we will. And then we have scholarship seats at the game, which is nice. We get all the free food and stuff. And then we'll just tailgate, hang out with friends. Oh, and my son's girlfriend is top 5 in this tournament at Auburn. So she might win. Like she's, yeah,
I've seen so many things on her.
yeah. So she,
That girl. At Auburn.
yeah,
Wait, that's his girlfriend?
yeah.
Always like connect with Carly.
Yeah.
Yes.
No,
Totally.
it's everywhere.
It's so goofy. I'm looking at these. It's so not like her. Like when she does these little videos, I'm just laughing my head off because I can just see her afterwards going, "Oh my gosh!" And she has to go and do this. I mean, it's hilarious to me because she's very dry, witty sense of humor. Do what?
Your son in any of the videos?
No, like he is the anti-her. Like she was her president of her sorority. She's a War Eagle girl. She's a spade. If you don't know what a spade is, like they pick the top 10 people on campus every year, but they only pick one girl because they used to never pick a girl, but they pick one girl. There's only if they do pick one at all. There's only been 8 in history, and she's a spade, which is a secret weird society. I mean, it really is almost kind of cultish. I lived with a couple of guys that were spades, and I'm friends still. And they like still wear like paper clips on their boxer shorts, or I mean, just weird, quirky things. You're like, oh, you're a spade, and nobody really knows unless you know them personally or you lived with them and saw the weird things. I just noticed patterns because I lived with one year, and I'm like, why do you wear a paper clip on your boxers? And then the next year, another guy had a paper clip, and I'm like, but they're real secretive, but anyway, so she's like all world. Campus involvement person. So she's got actually a pretty good shot of winning. Like there's zillions of people helping with her campaign. And usually like Alpha Gamma is really big into that, but they didn't have anybody up for top 5 this year. So they're like all on her campaign too. Like they have a lot of, if she doesn't win, somebody ran a really good campaign because she's a really sweet, likable kid. She went to Vestavia, so she knows a ton of people. That'd be kind of cool. You know, but we'll see.
Did someone beat Ann's record yesterday?
No,
I heard someone was really close.
it's so funny that it's the word on the street.
Oh, yeah.
No, he is capable.
We just took
He got back-to-back 30 seconds. But on the first 30 he got, which was like a week and a half ago, I was watching him because the The first time he took it, he did it in 40 seconds. The second time he did it in 33 seconds. And I'm like, oh my gosh, he could potentially do it.
This
No.
was the top
Um,
6 period.
Yeah.
Yeah.
Arjun was talking to us about
There's
it.
a kid right now, he's gonna beat the score.
It's so funny that they're talking about it. But no, I watched him on the third time he took it. He was just staring at his test. Like at 25 seconds, I started looking at him, and he's just going like this, just frozen for like 100,000, 200,000, 300,000. It was like I don't know. It seemed like 100 seconds, but it was like for this extended period of time, and then he goes, time. He just froze on one number, and he still got 30 seconds. So he.
6.25.
That's 5 to 6, but it was like 5 to 5th. Anyway, he just froze, and he's like, I know. He goes, and he told me this. I've been doing it in 26 seconds at home.
Wait, who was it?
Jackson Kittinger.
Was that the last time you
JK.
were taking it?
Do what?
Was that the last time you were taking it?
No, he took it yesterday, and I thought that was going to be it, and he did 30 again. But it had been, I think I snuck it up on him. It had been a week and a half. So I don't know. I'm going to give it one more time and give him another shot. I can't give him too many shots because Ham only took it like 4 times, maybe 3 or 4 times.
Oh, you're good in that class.
How's that?
Because you keep giving it to him, so like, he's like trying to get it. I don't remember. They're not like those. Arjun is Arjun. Yeah, because he said.
Argentina.
Yeah, and then tuna.
And like he said, it was his coach.
Yeah, climbing coach. I used to climb.
And I'm like, who just looks at a dark-skinned guy and throws him into South America? Like, he's not South American. Like, oh, Argentina. I mean, I'm like, dude.
We just all called him that.
Yeah, he must be from South America. Yeah, Argentina. I'm like, dude. I'm not. It is terrible. But his dad even calls him that. What? Everybody calls him that. Tuna. No, not Argentina, but they call him tuna because it evolved.
Oh, I thought you were saying everyone from Argentina.
No, it went Argentina to Argentina to tuna. Which is kind of a funny name.
I'm just going to Argentina.
I was like, you still go by that. Wait, what's the name?
A name is
I keep looking back over the worksheets, and I feel like every time I know a little bit less. Every time I look at it, I'm like, I don't know how to do this.
And then a name is like, it's a dance, like a music. Did the state ever, I don't know if relevant, the state,
Yeah, he's come out to the tournament. Yeah, he said that he has to coordinate with the other teachers and they're never on his campus because it sounds like excuses, but it's real. But in the limited time we've talked, it sounds like it's going to be more trouble than it's worth. So they're leaning towards a
Are
no.
there only 3?
At least for the fall. I mean, who knows? They might be something.
Here's phone number and 1. Did you do this thing?
That's awesome. They go. Be there at 6:30. Don't want to spend
Come on, good luck.
Yeah. Watch you play. Watch you compete.